Hi, my name is Shivam, and for my project, I've chosen poker, and my strategy is to play on a pair that's higher than an 8. So let's quickly take a look at the probability of achieving a pair um, from the beginning. So right now we have two random cards, and achieving any pair from 2 to 13 is 42%. This calculation is retrieved from Wikipedia, and I'll put that link in the comments. What we're focusing on is the top 6 pairs, so 9 to king. And the probability of achieving that is 19.5% because 42 divided by 13 gives about 3 point something, and that times 6 is 19.5. Now, you saw how the probability was calculated for us achieving a pair that's higher than 8. I would like to also show how dynamic programming will be used in this strategy. Let's say we have a 10 pair. Now, what pairs are greater than this? Meaning, what hands will we lose from? We'll lose from a jack pair, a queen pair, king pair, and an ace pair. Let's calculate the probability of us losing. So 42.2569% is the probability of getting any pair. We divide that by 13 to see each pair. That's 3.25, meaning the chances of getting jack, queen, king, ace are 3.25 each. And since there's 4 of them we're looking at, we'll multiply this by 4. And we get 13%. 100% minus 13% is 87. So we have about an 87% chance of winning with that pair. So if we're in the state of a 10 pair, our value of winning, so probability of winning, is 87%. This could be stored in a hash map of pairs and value. So we have a 10 pair, and the value of winning is 87%. So right now I just added some more values. So if we have a 3 pair, that means there's 11 pairs above us that could beat us, which is about 84.6% of pairs above us, meaning we have a chance of about 15% to win from that pair versus other pairs. So just like that, we will do the next calculation. So now we have a 6 pair, and below 6 there's a 5, 4, 3, 2, meaning 4. So there are 4 possible pairs that could beat us. We'll divide this answer by that. So there's a 30% chance that we will win that round. So all of these values are being stored in the hash, and these calculations will be referred to again using dynamic programming when these states are being called. Once these states are called, we'll get the values, which are these. And if the value is great and not small, we will proceed the game and we will follow the strategy to win. Sorry, little error. This was 87 before, and I had to switch it back to 70% just because I recorded the wrong value. So if I have a 10 pair, the value of winning is 70%. And if this state is called, then using dynamic programming, I will get the value of the win, which is 70. Let's calculate one more. So Jack, the probability of getting the pair is 42.2569. We're going to divide that by 13, get 3.25. Multiply that by how many are above us, which is 3. We get the answer of 9.75. 9.75 divided by 42.2569 is 23%. 100 minus 23 is about 77%. So just like that, I'll fill up these probabilities right now. So after calculating more values the same way, we got Jack, Queen, King, Ace. So if we have a Jack, the probability to win against another pair is 77%, Queen 85, King 92, and if we have Ace pair, it's 100% because there's no pair greater than an Ace. Although there could be a tie in all of these, but we are not looking for that. We are looking for probability to win. Meaning, even if it's a draw, that means we didn't lose. So we're looking for the probability of not losing. So the probability to not lose is 70%. But if you have a 10, and if you have a king, if you have an ace, then the probability to lose against another pair is 0% to lose. And the probability to not lose is 100% because you're not going to lose. There's no pair higher than an ace. Let's go through a quick demonstration. So here it's another opponent. There's 5 cards on the table, and these are our 2 cards. So let's check out what our 2 cards are. So we have a queen and ace. These are really good cards to start off with, especially because the suit's the same. But for our strategy, we're focusing on pairs. Let's start flipping through. We won't check these cards till the very end. 7, 5, queen. Oh, sorry. We will check that after. So now we have a queen pair. Using dynamic programming, we're going to refer to our table. So it says, having a queen pair, the chances of us winning against another pair is 85%. So I'm going to say, okay, let's play. I'm going to put my bets in, blah, blah, blah. The next one comes out. We're still going to play. And the next one comes out. King. Now, we still have an 85% chance to win. So let's see what the other person has and see if that 85% worked out or if we got unlucky and the last 15% won. So that person has an ace and ace 7. So this person has 7 pair. We have a queen pair, meaning our pair was higher than theirs. And this 85% calculation checked out. So when this set of queens was referred to here, it gave us a value of 85%. And that's through dynamic programming because we're going to keep on calling the same calculation over and over and over to see if we should play the game or if we should fold. That is how I will be using probability and dynamic programming to execute my strategy using sets of what we have and what can come. Hope that covers all the requirements, and hopefully that explained my strategy well and showed the mathematics behind that. Thank you for watching.